Hello ladies and gentlemen, this is Mr. Dang, and I will be making a lot of these videos to help you with this next couple of units here. So if anytime you have questions or you need tutoring, please stop by my room in 503. I will be ready to help you, and so don't hesitate to get help when you need. Okay, the nice thing about these videos is you can watch them over and over again at home on your phone. You can review these, pause them, replay them. So take advantage of it. So today we will be talking about periodic trends. By now you should have your periodic table was colored. You should know about those periodic groups, properties of different elements, metals, nonmetals, and metalloids. So review that. If you don't have that good handle of that, please read over your coloring packets thoroughly and study those materials. In front of you, you should have these handouts. I'll show you one at a time here. Periodic trends, this introduction handout. We'll do this first, and then I'll go over some slides for notes on a PowerPoint. So have your notebook ready to take some notes. Then you'll have this paper here, and two-sided. All these are printed two-sided, so don't glue this into your notebooks. You'll fold this, and then you'll put in a pocket if you have a pocket in your notebook. And periodic trends, this last worksheet to practice. Okay, this concept about periodic trends is fairly simple, but only after you understand and get it. And I'd like to take a moment here to introduce you to this idea about reading graphs and analyzing a graph first and applying this new concept as well. So I don't expect you to understand these concepts right away right now, but this is a great way to get you introduced to this concept of periodic trends. Okay, so when Mendeleev and Moseley arranged the periodic table, they saw this repeating pattern. That's why they were able to sort them in different rows. Each row has a unique set of properties that repeats, and so these repetition is called a periodic, and a trend is a pattern. It's repetition of a certain pattern of properties. Okay, so periodic trend, and we know like period of time, and so other concepts of periodicity, that is just a cycle that goes over and over again. Okay, so there are 4 graphs on this paper. The first one talks about atomic radius, which is just the size of the atom. Okay, when the periodic table arranges in a way that there's a pattern on the size. And when we talk about these periodic trends, it applies primarily for representative elements, just elements in groups 1, 2, 13 through 18. Transition metals behave a little differently, so we skip over the groups in the middle, 3 to 12, and it applies really to these elements in the represented groups a lot better. They don't always follow these rules, but this is the general pattern. And so directions here says use a highlighter, marker, or colored pencil to draw a vertical line where each period ends. The period is the row, where each row ends. So the first row ends on element number 2. The second row ends on element number 10. The third row ends on element number 18. And the fourth row ends on element number 36. You'll do this for every single graph, all 4 graphs. Shouldn't take long, should be fairly quick. So, first thing, the size. What do you notice as we go across, on the same period? So each of these line is 1 period. This is row 1. This is row 2, this is row 3, which is period 3, and this is row 4, period 4 right here. As we go across each period, what do you notice about the size of the atom? This is going which direction? It's going downward, so there is a decrease from left to right. So radius, decrease. It gets smaller. Okay. And then from going down each group now, is we jump from period 1 to period 2, we're going down the group. What's happening to the size of the atom? Here's the first element. It goes to there's the first element. What do you notice? What do you notice the general trend is? They are actually increasing in size. So going down from top to bottom, the radius increase. The atom is actually getting bigger. So you don't need to know the reason now. I will go over the slides and it'll explain why it's getting bigger or why is the atom getting smaller. Okay, so that's the first one, atomic radius. That's what you need to do. You need to tell me, how do you read this graph? What does this graph tell us? Okay, and the second graph, it's not very clear in your paper, but there are two trends here: atomic radius and ionic radius. I'm going to use an ionic radius. Here's atomic radius. Atomic radius is the line that starts with element 1 and 2 here. That it starts with 53 and 31. So trace that with a different color, because it didn't print out. On my printout it was blue and green, but with black and white printout it's not very clear. So I'm going to do orange and pink here so you can tell. So what do you notice? Is there a general pattern? Okay, the radius is going to decrease across each row. As we go across, it's going to increase as we jump from one row to another. But notice there's no pattern. Right here, for example, element number 3. The rate ionic is less than atomic. And then at element number 9, ionic is greater than atomic. So there's no general pattern. So guys, it depends. Sometimes ionic is larger, and sometimes ionic is smaller. And I will tell you why in a little bit, okay, when we go over the notes. So, but I just want you to see there, it's not always the same. Over here, basically this group, all the ionic. Somehow this last group, almost all, or from 19 to 31, all the ionic is smaller. Ionic is the orange line, is smaller than the atomic. Okay. If you flip it over, take a minute to tell me what these trends are. Pause the video, whatever you need to do. So first, element 10 stops right there. Element 18 stops right there. Element 36 stops right there. And then element 2 doesn't have one. Okay. So, what's the general trend? Just write a few notes here. What's the general trend from going like that across a? This is across a period, across a row. This is across a row right here. This is across a row. What do you notice? Is it increasing? Is the electronegativity? This is a new trend. It's not size anymore. Electronegativity, attraction for electrons. Okay. Is it increasing? And so write some notes on here. What happens as we go to down the group? Like first element, what's happening to, like, compare the first element, compare the second element. What's the general trend? Is it going up or is it going down? So write a couple notes. Left to right, what's happening? Left to right is the orange highlights here. Okay, and then top to bottom, what's the trend here? So write a note about that. And then do exactly the same thing with the next graph. So here, split up. The first row ends right there. 2, 10, 18, and 36. We can ignore these jumps here. They're not supposed to be there. Okay, treat them as if they're not there. So going across a row, the general trend of ionization energy. This last one's about ionization energy. Going across a row. Going across a row, a period. What's happening to the trend? It looks kind of the same as the electronegativity, right? It's going in the same direction, going across. Going down as well. Look at this. Ionization energy and electronegativity sort of have the same trend. Alright? And so, have this ready. I hope this kind of introduced a little bit to you about what this is. So we will go on to the slides.